This image is often called the most intelligent photo in history. It was taken at the 1927 Solvay Conference in Brussels, Belgium, one of the most famous gatherings in the history of science. The photo includes 29 of the greatest physicists of all time. But if you look closely, you'll notice something odd. All of them are men, except for one woman seated in the front row, fourth from the left. She's surrounded by legendary figures, yet clearly belongs among them. That woman is Marie Curie. She wasn't just there as a participant. She was the first person in history to win 2 Nobel Prizes in 2 different fields. That's why she's called the mother of modern physics. Marie Curie's life was extraordinary from beginning to end because she spent most of her life working with radioactive materials. Her personal notebooks, lab equipment, and belongings are still radioactive and stored in lead-lined boxes in a Paris museum. Even after her death, the radiation from her body was so intense that her coffin was sealed with lead. But what exactly did this woman do to earn such status? And what's the story behind her radioactive grave? Marie Curie is one of the most influential people in science history. Work didn't just revolutionize physics and chemistry, it also laid the foundation for modern medicine. She came from very modest beginnings, born in Warsaw, Poland in November 1867, when the country was under Russian rule. She was the youngest of 5 children. Her father, Władysław Skłodowski, was a teacher of physics and mathematics and a non-religious man. Bronisława was a devout Catholic who ran a boarding school for girls. Marie faced tragedy early in life. Her mother died from tuberculosis when she was just 11, and her sister died of typhus 2 years later. These experiences led her to abandon Catholicism and adopt agnosticism, despite education restrictions on women in the Russian Empire, which was illegal but allowed women to study science and other disciplines. She knew the risk. Just attending could land her in prison. At the time, Russia and Germany were trying to erase Polish culture, including through control of education. Polish people were forbidden from shaping their own curriculum, and most professors were foreign. Marie graduated from high school in 1883, then spent a year with her father's relatives in the countryside before returning to Warsaw to work as a private tutor. In her teens, she made a pact with her sister Bronia. Marie would support Bronia while she studied medicine in Paris, and later, Bronia would help fund Marie's studies, so Marie worked for 6 years as a governess and tutor, studying science in her spare time. Her passion and intelligence helped her persevere. Finally, in October 1891, at the age of 24, Marie moved to Paris to attend the Sorbonne, studying physics, chemistry, and math. She couldn't study in Poland, as universities didn't admit women. In her memoirs, she wrote, "It was like a new world opened up before me, a world of science I was finally free to explore." She studied during the day and tutored at night to survive. In 1893, she earned a degree in physics, and in 1894, a second one in math. That same year, she met Pierre Curie, a French physicist known for his work in crystallography, magnetism, and piezoelectricity. They shared a deep passion for science. Pierre quickly realized she was the partner he was looking for, not just in life, but in the lab. They married in July 1895 and had 2 daughters, Irene and Eve. Their bond was strongest in the lab. In 1895, Wilhelm Röntgen discovered X-rays, but couldn't explain their source. A year later, in 1896, Henri Becquerel discovered that uranium emits invisible radiation that could penetrate objects without any external energy source. It was a mystery. To Marie and Pierre, this was a scientific goldmine. Marie decided to dedicate her PhD research to uranium radiation. She soon proved that radiation came not from chemical reactions, but from the atom itself. Pierre joined her work, abandoning his own research. Together, they spent years studying radioactive elements, changing how scientists viewed atoms. In 1898, the Curies discovered 2 new elements: polonium, named after Marie's homeland radium, which would become central to cancer therapy. These discoveries shook the foundations of physics and chemistry, Radioactive materials consist of heavy atoms with large nuclei. These nuclei are unstable and naturally emit energy to return to a more stable state, a process called radioactive decay. Marie proposed that this energy emission came naturally from the atoms, without any outside interference. This was revolutionary. It meant atoms were divisible, supporting later theories about atomic fission. Radium, once purified, looked like a pale white powder, indistinguishable from salt. When decaying, it emitted helium nuclei alpha particles and electrons. Underwater, these electrons moved faster than light in that medium, producing a blue glow. In 1910, Marie saw this glow and recorded it in her notes, though she mistakenly attributed it to phosphorescence. In fact, she was witnessing what we now call Cherenkov radiation, officially discovered in 1934. In 1903, Marie Curie won the Nobel Prize in Physics, shared with Pierre and Henri Becquerel. Her work wasn't just a scientific milestone, it also challenged gender norms. She became the first woman to win a Nobel, and in 1911, she won the Nobel Prize in Chemistry for isolating pure radium, becoming the only person in history to win Nobels in 2 scientific fields. Her discoveries transformed medicine, especially cancer treatment. She and Pierre found that radium could destroy diseased cells faster than healthy ones. During World War I, she developed mobile X-ray units to help diagnose soldiers' injuries on the battlefield, saving countless lives. Her work also impacted energy, technology, and medical imaging. The principles of radiation she uncovered are still used today, but the cost was immense. Long before the dangers of radiation were understood, Marie handled radium and polonium bare-handed, sometimes even carrying them in her pockets. She took radioactive materials home. Her body absorbed massive amounts of radiation over time, causing her to develop chronic illnesses, including aplastic anemia. Despite her illness, she kept working. She founded the Radium Institute, now Curie Institute, in Paris, dedicated to advanced research in physics, chemistry, and medicine. The institute became a magnet for brilliant scientists, many of whom later won Nobel Prizes. Marie Curie died on July 4th, 1934, at age 66, from aplastic anemia, a rare blood disease caused by radiation. In 1995, the French government decided to move her remains to the Pantheon, a national mausoleum housing the greatest French figures, like Victor Hugo, Rousseau, and Voltaire. When gravediggers opened her coffin, they found elevated radiation levels. Her wooden casket was lined with 2.5 millimeters of lead. Shockingly, her body had remained strangely well preserved. To this day, Marie Curie's grave, belongings, and notebooks are still radioactive. They are kept under strict conditions in a Paris museum.